This galaxy should not feel old. Not because it is far away, because it isn't supposed to have a past yet. When the James Webb Space Telescope looked deep into the early universe, it found a tiny red galaxy, now called JADESGSZ140. We are seeing it from a time less than 300 million years after the Big Bang, less than 2% of the universe's current age. And later observations found something that made it much harder to treat as just another distant smudge: oxygen. That one detail changes the mood of the entire picture, because oxygen is not part of the universe's first simple draft. Oxygen has to be made inside stars, which means that by the time we see this galaxy, stars had already formed there, lived, and started changing their environment. In plain English, this thing is not just early, it already has history. And that is where the clean textbook image begins to crack. We tend to imagine the early universe as a kind of cosmic nursery. Hot, yes. Dense, yes. But simple. A place where structure was only just beginning to show up. The first stars, the first fragile galaxies, the first quiet steps toward the rich universe we know now. But this does not look like a quiet first step. It looks more like walking into a newborn's room and finding smoke in the air, footprints on the floor, and a fire already burned down in the fireplace. That is the real surprise here. Not just that Webb saw far, but that when it got there, the beginning already looked busy. On screen, you would start with a deep field. At first, it just looks like darkness scattered with faint specks. Then the camera pushes in on one almost absurdly small red point. A dot so tiny, it feels like nothing. And yet that dot is a message from a time when the universe was still in cosmic childhood. NASA describes JADESGSZ140 as the most distant confirmed galaxy known, and ALMA later detected oxygen in it. That is the first payoff. The second comes when you ask what oxygen actually means. A lot of space videos throw element names at you and move on. But here, the element is the point. Hydrogen and helium are the easy ones. Those belong to the universe's opening act. Oxygen does not. Oxygen is forged later, inside stars, then thrown back out into space. So if you detect oxygen in a galaxy this early, you are not looking at something pristine. You are looking at a place that has already been worked on, already processed, already changed by stellar life. That is why this galaxy feels older than it should, young in time, old in chemistry. And once you feel that contradiction, a deeper question opens up. What exactly were scientists expecting to see when telescopes finally reached this far back? Not nothing, but something simpler. The broad picture of cosmology is still extremely successful. The universe is about 13.8 billion years old, and that estimate is anchored by several lines of evidence, especially the cosmic microwave background, measured in detail by missions like Planck. The early universe was hot and dense, then expanded and cooled, then eventually allowed atoms to form, then stars, then galaxies. That framework still stands. But within that broad picture, there is still a timeline. And timelines can be wrong in the details without the whole map being thrown away. That distinction matters, because this is not one of those stories where everything scientists thought was nonsense and one telescope broke the universe. That is too easy, too loud, and not actually what the evidence says. The real story is better than that. The map still works. The roads got stranger. If you compress the age of the universe into a single year, JADESGSZ140 appears in the first week of January, and yet it already shows signs that some stars had enough time to form, live, and enrich their surroundings. That is what makes this galaxy feel less like a blank beginning, and more like the aftermath of events we did not expect to fit so early. Now the camera pulls back, because the real mystery is not one galaxy. One weird object is interesting. A pattern is dangerous. Part of the reason Webb caused so much excitement is that it did not just look farther. It looked better. It was built to see the infrared universe with extraordinary sensitivity, which matters because light from very distant early galaxies has been stretched by cosmic expansion out of the visible range and into infrared. Webb was designed for this exact job, to look back toward the era of first galaxies. And when the data started arriving, the early universe did not feel as primitive as many people expected. Some of that early panic has been softened. A few initial crisis headlines turned out to be too dramatic. In some cases, bright early objects were not necessarily as massive as first feared. In others, better analysis brought estimates back closer to what current models could tolerate. But that does not erase the tension, because the most interesting version of the mystery was never just, we found galaxies early. It was, some of them already look developed. That is a much harder feeling to shake. And JADESGSZ140 is the perfect symbol for that. It is like seeing a skyline before sunrise. The lights are on too soon. The structure is there too soon. And now the viewer's first question gets replaced by a bigger one. Not, how did Webb see this far? But, how did the universe get this far, this fast? That is the midpoint upgrade. And it is where the script stops being about telescope achievement and becomes a story about cosmic speed. Because once you notice this pattern, you start to realize how human the old picture was. We like beginnings to be clean. We like origin stories where page 1 is simple, page 2 is complicated, and everything builds in the order our intuition wants. But the universe has never shown much respect for human intuition. Even in ordinary life, beginnings are messy. A forest can look ancient long before it feels fully grown. A city can carry history within decades. A face can look young and tired at the same time. So maybe that is the deeper lesson here. Maybe cosmic beginnings are not blank. Maybe they are fast. Fast in ways our instincts are bad at imagining. And this is where you can give the viewer something bigger than a science fact. You can give them a new picture. Instead of the early universe as a dark waiting room, picture it as a place where change was happening everywhere at once. Matter collapsing, stars igniting, ultraviolet light flooding space, the first stellar generations living short, violent lives, heavy elements beginning to appear, tiny systems racing through stages we usually spread out over vast mental distances. Not mature in the sense of finished, but not innocent either. That is a much stranger beginning, and a more interesting one. At this point, a weaker script would start drowning the viewer in terminology. Redshift, metallicity, star formation, efficiency, reionization, feedback, accretion, all useful ideas, all dangerous if introduced like homework. So instead, keep the physics attached to consequences. If oxygen is there, something already burned. If stars already burned, then time is not the only issue. The issue is pace. How quickly can gravity gather matter? How quickly can stars form? How quickly can they live and die? How quickly can a galaxy stop looking chemically newborn? Those are not abstract questions anymore. They are all hiding inside one red dot. And that is why this discovery matters to people who do not care about astronomy most days. Because this is not really a story about a telescope. It is a story about how easily reality outruns the pictures in our heads. You were probably taught a neat version of the beginning. A clean one. Hot plasma, then atoms, then stars, then galaxies, then everything else. And at the broadest level, that picture still works. But what Webb is doing is forcing texture back into that story. Not chaos. Texture. The kind that makes a beginning feel less like a diagram and more like a real place. A real place can surprise you. A real place can move faster than expected. A real place can already carry traces of what came before. That phrase matters. What came before? Because JADESGSZ140 is already ancient in one very specific sense. Not by the clock, by inheritance. It already inherited the work of earlier stars. That is what oxygen is telling us. Not that the universe is older than 13.8 billion years, not that the Big Bang never happened, but that by the time the universe becomes visible to us in these extreme early galaxies, some places may already have burned through more story than our older mental picture allowed. And once you see that, the ending writes itself. The beginning of the universe may still be lawful, it may still be describable. It may still fit inside a model that has enormous explanatory power, but lawful does not mean intuitive, and early does not mean simple. That is the line I would want the viewer to carry with them after the video ends, because it changes how you look at the sky. That small red dot is not just far away. It is evidence that even cosmic childhood may already contain memory. If you could somehow stand there, not survive there, just witness it, you would not be looking at a blank first chapter. You would be looking at a place where the universe had already started writing over itself. A beginning with fingerprints. A beginning with ash in the fireplace. A beginning that arrived already carrying history. And maybe that is the most unsettling part of all. Not that the universe is mysterious, but that the closer we get to its first visible moments, the less those moments behave like a clean beginning should. They behave like the aftermath of events that happened almost too fast to believe. So, no, we probably did not get the universe completely wrong. But we may have gotten one very human thing wrong. We thought the beginning would look innocent. Webb keeps suggesting it did not. And that is why this tiny, ancient, oxygen-bearing galaxy matters. Because in one of the earliest places we can see, the universe already looked older than it had any right to,